Okay guys, so I am going to start this recording and just kind of wing it going through this, but if you're going to really follow along and get anything from this, then attached next to this video on Schoology, you're going to see a copy of this review, okay? So what I'd recommend doing is at least being able to see this review, writing down the problems with me as I go through each type. I might do maybe one or two, well, definitely do one of each type, maybe two of some types that I think might be more difficult. But I'm going to start off in this first section. But even before I do that, I'm going to list out some rules that you guys need to be familiar with. Like, for example, all these rules deal with exponents. So we already know how to multiply numbers, so occasionally we're going to come across problems that have numbers in them, and if you need to multiply the numbers, guys, you already know how to do that, or divide the numbers, you already know how to do that. So these rules specifically pertain to exponents. So there's a rule that says if you have a to the m times a to the n, what you want to notice about this rule is they have the same base. So if you have the same base, right, and they have different powers, but they're being multiplied with each other. So it's the same base, right, being multiplied with each other. That means you can add their exponents. So, for example, like 5 to the 6 times 5 to the 7th equals, notice the same base, 5, to the 6 plus 7. 6 plus 7 is 13. So that's the same answer, right? And more often than not, you're not going to have a 5, you're going to have like a variable or something like that. But all that matters is that you have the same base. So there's one rule. Same thing for division. Oops. If you have like a to the m divided by a to the n, then instead of adding, you're going to do the opposite of adding. You're going to subtract. A to the m minus n. So if you have two numbers, same base, right, being divided by each other, then you can subtract their exponents. So let's use 5 again. 5 to the 7th divided by 5 to the 6th, and that's the same thing as 5 to the 7 minus 6, which is just 1. Okay? Occasionally, you're going to see negative numbers when dealing with this as well. So remember that things like this, 5 to the negative 1, okay, that's the same thing as instead of multiplying by 5, or let's say like negative 2, instead of doing 5 times 5, which would be 5 squared, that's 5 times 5. This, with a negative exponent, actually means divide by 5 twice. So instead of multiplying by 5 twice, that's what that actually means, okay? So I taught you guys that when you have a negative exponent, you can actually, it's the same thing as putting it on the other side of the fraction bar, okay? So you have 5 squared and making it positive like that, okay? So remember, negative can be put on the other side of the fraction bar and made into being positive. So for example, another one, say I have a to the third divided by a to the negative 2. Okay? Well, I can take that a to the negative 2 and put it on the other side of the fraction bar. So a to the third is already up here on this side of the fraction bar. I can also take a to the negative 2 and put it on top, making it positive. Okay? Remember, it's a negative exponent, so you can put it on the other side of the fraction bar. Everything divided by 1 is just itself. That's why I can put a 1 there. A to the third times a squared. Well, that takes into account now this rule again, where it says two things multiplied by each other with the same base, a, you can add their exponents. So a to the 3 plus 2, which is 5. And you can put it over 1 if you want. But that's how these rules kind of work together. So I just wanted to remind you also of negative exponents. Negative exponents play a big part in what we're doing here as well. And last rule is, now a lot of people get this confused, but look at the difference. When you have a to the m times a to the n, then it's a to the m plus n. But if I have a to the m, then that is raised to the n. A to the m to the n, okay? I call this having a power to a power rule, okay? That's the same as a to the m. Instead of plus now, it's going to be times n. All right, so like for example, let's go back with our faithful 5. So 5 to the 7 to the 6th power is the same thing as 5 to the 7 times 6. Okay, what is 7 times 6? 42. That's what that would be, 5 to the 42nd power, because 7 times 6 is 42. So these three rules, if you're writing notes on this video, then those three rules are what you need to be very familiar with for this test, okay? And if I erase that too fast, then go back and pause it and then write it down, all right? So I'm going to go ahead and do number 18 on the first section right here. The first section is just says multiply the following monomials using the rule an to the am equals a to the m times n, all right? Also, you'll notice on here, and I know you can't see this, but I'm talking about the first section. At the very top, it says lesson found on Monday, 3/13/17. If you go on Schoology on that date, right? Remember, everything's organized by date in those folders. Right there, you're going to see a lesson on this stuff. All right. So number 18, that's the one I'm doing in the first section. It says -2 times c to the 4th times d, all right? All of that being multiplied by -4 cd. Okay, so notice this is all just one big monomial actually. There's no, you're not adding or subtracting. Everything is multiplication, all right? So like I said at the beginning of this video, when you're dealing with numbers, just regular numbers, I'd start off with that and just multiply them. We already know how to do that. So -2 times -4, -2 times -4 is +8. Negative times a negative is a positive. C to the 4th times c to the, remember if something doesn't have an exponent, it's to the first degree. Okay, it's not that the exponent's not there, it's just we don't usually put it there. So c to the 4th times c to the 1st, notice they have the same base, c and c. So you can add their exponents. 4 plus 1 is 5. So that's c to the 5th. D to the 1st times d to the 1st. So d and d, right? So same base, add the exponents. D squared. Okay, that's it for the first section. Well, no, I lied. So there's also the power to a power rule. And again, guys, I'm going quick. So every time I'm done with one of these, if you want to copy it down, pause the video. So number 22. Number 22, I'll write it over here. Number 22. Number 22 says -3y to the 3rd. Oh, -3y, and then actually the parentheses is here, to the 3rd. So you got to realize that this is -3 to the 1st and y to the 1st. Okay, so -3, now this is a power, right? First power to another power. It's a power to a power. So remember, if you go back and look at that rule, it says that you can multiply those powers together. So 1 times 3 is 3. And y to the 1st times 3, 1 times 3 is 3 as well. So -3 to the 3rd, I'm just going to simplify one more step. -3 to the 3rd, so this equals that, which equals -3 times -3 is 9, times -3 is -27. -27 y to the 3rd. Okay, that would be simplifying something like number 22. Let me go ahead and do one more just so I can cover everything that you guys might have a question about. Let's do number 24. Number 24 is 2b cubed c to the 4th squared. Okay, so remember that's there's a little 1 there, even though it wasn't there. Okay, so I'm going to rewrite this. 2 to the 1st to the 2nd, so that's 1 times 2, so 2 squared. B to the 3rd to the 2nd is 3 times 2, that's 6. C to the 4th to the 2nd, 4 times 2 is 8. So I'm simplifying. This is the same thing as this, which is the same thing as 2 to the 2nd power is 4b to the 6th, c to the 8th. And that would be it simplified. Okay, next section. Now we're going on to some division. I'm going to go ahead and do number 12. Number 12 on the next section. Now we're dividing the monomials. So remember, when you're dividing monomials and you have the same base, you can subtract their exponents. Okay, so here's number 12. start off with 32 divided by negative 8, just the regular numbers. 32 divided by negative 8 is negative 4. Done with those. Makes it a lot easier to look at. Okay, this is x to the third divided by x to the first. So we have the same base, so we're going to subtract our exponents. 3 minus 1 is x squared. Okay, that's those. Those are done. 2 minus 1, so I have same base of y, so I can subtract. 2 minus 1 is 1. Done with those. Z to the fifth divided by z to the second, so again, same base. And then 5 minus 2 is going to be third. And that's the answer right there. So really pretty easy, as complicated looking as it might be, to actually simplify these monomials is very, very easy for the most part. Let's do another one. Let's do number 18 is, so 18. H to the third divided by h to the negative 6. So remember, when you have a negative exponent, you can take it and put it on the other side, make it positive. So this is actually just h to the third was already on top. I'm going to put h to the 6th on top and make it positive because it was negative. So if there's nothing on bottom, you can put a 1 there, or honestly, now that I've told you that, I'm just going to say you don't have to have a bottom. Okay? If you don't have a top, you definitely need to put a 1 on top. Just remind yourself that what you have is in the bottom. But if everything is on top, then you don't need a bottom necessarily. H to the third times h to the 6th, you have the same base. When it's multiplied together, you can add their exponents. So h to the 3 plus 6 is 9. And that's the answer. All right. If you have something like, really quick, number, let's say, 17. You have something like this, 9 divided by 11 to the negative 1. So remember, this is 9 to the first and 11 to the first. And when you have a power to a power, you need to multiply 1 times negative 1, which is negative 1 over 11 to the negative 1. So realize you just have a negative exponent on top and bottom. So you're really just going to switch it. So it's going to be 11 to the first up top, 9 to the first on bottom. So notice both exponents switch and become positive. And that's the answer. Okay. Next section, scientific notation. Okay, so all scientific notation is, I guess I'm gonna start with this. Let's do this first. So number 1 is take, looks like 3,400,000 or 400 million or something like that. Yep, 3,400,000,000. Take that, put it in scientific notation. So remember, in scientific notation, what you want is when something is in scientific notation, you want a decimal in this location right here, where you have 1 digit to the left. Okay, so if I'm working with something like, let's just do 2 of these at once. If I'm doing something like number 5, which has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I hope I counted that right, but that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros, and then an 8. Again, I want, in scientific notation, a decimal place here, where I have only 1 digit to the left. Always, consistently, you just want 1 digit to the left. All right? So in order to do that, I need to realize how many places, here was my decimal on number 1. How many places did that need to move to get here? I needed to move 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So my scientific notation written out would actually be 3.4 times 10. Now, how many times did that my decimal place move? Moved 9 times. So you just write it with your, like in the ideal place for your decimal, where there's 1 digit to the left. Okay, write that. Then times 10 to the however many times you need to move the decimal place. Now, if I'm moving it left, notice my number is it's positive. If I'm moving it right, okay, then my number is going to be negative, and that's why I wrote down this next example. So in this case, ideally, I want my decimal place right there. So how many places did I have to move to the right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm going to say 8.0, right? That's where my decimal is, times 10 to the negative 11th. All right. Honestly, the way I remember it is in scientific notation, if my number that I'm putting into scientific notation is smaller than 1, right? It's like a really small decimal. I should have negative exponents. If it's a really big number, a huge number, then I should have positive exponents. All right. So that's scientific notation, just the basics. Now later on, further down on the page, you have tougher scientific notation problems like something like, let's see. Well, I guess I skipped a certain area real quick, so let's do that. 7.15 times 10 to the 8th. This is number 10. I'm just going to do this very quickly. So now, again, positive exponents. So you should know this should be a very big number, or also you should know that to undo those, I need to move it to the right. All right, so 7.15. I said a second ago, I need to move it to the right. What I mean by it is my decimal place. I need to move it 8 times. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's my new decimal. That's how many zeros I need to have. A lot of people think that they need to have 8 zeros. That's not the truth. Okay, so in reality, what's happening is the decimal place is moving 8 times. So notice, in this case, I only needed 6 zeros. So my answer is 715 with 6 zeros. If I want, I can put my decimal place there. So it's 715 million. All right, and that's going in the other way. That's taking something in scientific notation and writing it in standard form. Okay, continuing on. The tougher type of scientific notation problems, which actually really aren't tough at all, is something like number 13, which is 6.1 times 10 to the 5th. And this is where we start mixing in everything we've learned. 2 times 10 to the 5th. All right, so when I can take these two numbers that are in scientific notation, multiply them together, why it's convenient that they're in scientific notation is because 10 and 10 have the same base. And when I multiply two things with the same base, I can add their exponents. Remember that rule that says a to the m times a to the n is the same thing as a to the m plus n? That's what we're using here. So again, start off with your regular numbers. We know how to multiply that. 6.1 times 2 is 12.2 if you need a calculator for that. Then I'm just going to write times 10, so times 10 to the, well, 10 times 10, 10 to the 5th times 10 to the 5th, same base, I'm going to add 5 plus 5. 10 to the 10th. Okay? And that's good enough for my answer. Now, in reality, to put this in scientific notation, you actually need to move this decimal place 1 spot to the left. Because remember, scientific notation should only have 1 decimal to the left. So if I move it to the left, that means this number should be 1 place even bigger. Okay? So it actually should look like that. That's the actual answer in scientific notation. But what we're testing here is just your understanding and your ability to see that these have the same base, so we're just going to add our exponents, right? So let's do another quick example. I want to do one with some negative exponents. Number 16 is good. 16 is 1.35 times 10 to the 8th. Multiply that by 7.2 times 10 to the negative 4th. Okay, so in my calculator, I'm going to not really answer this, but in my calculator I'd start off by multiplying 1.35 times 7.2. I don't know what that is. I'm going to guess it's like 11 something. So I would have my answer as like 11 something. I don't know. But then I'd do times 10 to the, and notice, same base, times 10 to the 8 plus negative 4. 8 plus negative 4 is 4. So my answer would be whatever these two numbers multiplied together would be, times 10 to the 4th. All right, I want to make sure I'm still recording because I know that this thing just ran out of batteries. So, yep, that looks good. Okay. So next part, write each question in standard form, or write each polynomial in standard form is the way I should have worded that. So I'm going to do number 21. It's fairly long, so I think that's better. So number 21 is 6x cubed minus 7x to the fifth plus x minus 2x squared plus 1. So we're going to write it in standard form, and we're going to identify the degree and leading coefficient. Okay, so standard form, well, let's start off with this. Let's talk about degree. Then we're going to do standard form. Then we're going to talk about leading coefficient. That's an L. Leading coefficient. Okay, so the way you identify all of this stuff, or you organize it in standard form, all of it is based on exponents. So when you look at each individual term in a polynomial, so remember, a term is any piece of that polynomial or any part of the expression that's separated out by a plus or a minus sign. Okay, so right here, this negative 7x to the fifth, that's one term, or 6x cubed is one term, or just the x here is one term. Okay, so all these things are being separated out. The degree of a polynomial is when you look at all those terms and you figure out which one has the biggest exponent. All right, so right here we have x to the fifth, so the degree of this polynomial is going to be 5. This is a degree 5 polynomial because the biggest term, the term that has the biggest degree, is fifth degree. So it's going to be degree 5. Now, in standard form, what you're going to do is rearrange this polynomial to write each term from the biggest degree all the way down to the smallest degree. All right, so we already determined that this is the biggest degree, so I'm going to start off by writing this term. That's the beginning. Okay, done. Next biggest term is going to be this one right here to the third degree. Okay, so plus 6x cubed. That's the next biggest term. Next biggest term is to the second degree, minus 2x squared. Next biggest term is to the first degree right here, plus x. And then the last biggest term doesn't have a variable, so it actually is to the 0 degree. Okay, or yeah. So it doesn't actually have a degree at all because it has no variable. So if you notice, when it's in standard form, here it is. Fifth, third, second, first, 0. Okay, so it goes from biggest to smallest in order of degree. Once you have it in standard form, to identify the leading coefficient, it's just whichever coefficient is on your leading term, okay, or the term with the biggest degree. So in this case, it's just negative 7. And remember, a coefficient is just the number in front. It's not the whole thing. It's not the x to the fifth. So my leading coefficient is only negative 7. All right, so that's that section. Yeah, that should be enough for that section. Let's see. So going on to the last page. I'm going to do number 1 from each section real quick because it just leads up. So this is actually pretty basic stuff. We're just distributing, pretty much. We're distributing monomials. Or you can call it multiplying polynomials if you want. If you want to type it into YouTube or something and find a video, multiplying polynomials or multiplying a monomial by a polynomial. In this case, that's a trinomial. Anyway, so you just distribute like this. You want to make sure that that monomial on the outside is multiplied by everything on the inside of this parentheses one time. Okay, so I'm going to start off negative 3 times negative 2. We know how to multiply the number, so I'm doing that. Negative 3 times negative 2 is 6. Now, n squared times n squared. Remember, they have the same base, so I'm going to add their exponents because of the rule that says a to the n times a to the n. Two numbers with the same base, you can add m plus n, their exponents. Okay? So, negative 3 times negative 2 is 6. N squared times n squared, same base, so add their exponents. 2 plus 2 is 4. So that's, this one is done, this one times this one. Negative 3 times 3 is negative 9. N squared times n to the first is n to the 2 plus 3 is, or 2 plus 1 is 3. That's that one done. Negative 3 times 4 is negative 12. n squared times, there's nothing over here, so I'm just going to write n squared. That's that one, okay? And that was number, I'm sorry, I didn't say that portion. I'm sure if you were looking at it, you could see it though. It's number 12. That was number 12 on that last page, first section of the last page. Okay, next section is doing the same thing, and then we're going to just combine some like terms. So let's do number 20. Number 20 of, like, toward the middle of the page. All right, it says 3m times 3m plus 6 minus 3 times m squared plus 4m plus 1. Start off with distribution. So we have a number on the outside of a parentheses. I'm going to distribute just like I did that last example. 3 times 3 is 9. M times m, that's to the first, so that's going to be m squared. 3 times 6 is 18. M times nothing is just going to be an m. Negative 3 times m squared is negative 3m squared. So the way I did that was negative 3 times, there's a 1 in front. Negative 3 times 1 is negative 3. Nothing here, no variable multiplied by the m squared is just going to be an m squared. Negative 3 times 4 is negative 12. Nothing here multiplied by that m is just going to be an m. Negative 3 times 1 is negative 3. So I multiplied everything out by distributing, and now I'm going to combine my like terms, and it's really that simple. So 6m squared minus 3m squared is going to be, I said 6 I think, but 9m squared minus 3m squared is 6m squared. 18m minus 12m. So notice, again, what makes something a like term, I talked about this, is that it has the exact same variable expression portion, like the term has the exact same variable expression. So m squared and m squared, I can combine these two. So 9 minus 3. Or m and m, I can combine these two because of the exact same variable portion. M and m. Okay, so 18 minus 12 is 6 m's. If I have 18 m's and I take away 12 m's, I have 6 m's left. Minus 3, and there's nothing else to combine it with, so minus 3. So that's how you do that portion, and that would be the answer. So you need to multiply it and then combine like terms. And then lastly, and I realize this is a really long video, but let's go ahead and finish it off strong. So last section, now there's a solving element in there. So number 22, and this is going to be kind of long. So I'm going to start off a little bit higher, and if you can't see it, then hopefully, like I said, you're looking at the review in front of you. Start off by distributing. 2 times 4x, 2 times 2. So 2 times 4x is going to be 8x. 2 times 2 is going to be 4. I have a minus 8 here. So notice I'm not distributing onto that minus 8 because it's not inside the parentheses. So I'm going to combine like terms here in a second. 4 times x is 4x, and 4 times 3 is 12. Like I said, I'm going to combine like terms here. So 4 minus 8, so I have 8x plus 4 minus 8, so minus is going to end up being a minus 4 equals 4x plus 12. Now here comes the solving element. So I have an equal sign over here. I want to continue to combine like terms, but this time I'm combining over the top of an equal sign, right? So I can't just add 8x and 4x. They're on opposite sides of the equal sign. So I need to find a way of getting those things together. So let's get the 4 and the 12 together. Let's start off with that. So I have a minus 4, and if I want to get that off of this side, I want to take it away from this side and put it on that side, I need to add 4. That's the trick with combining like terms over the top of an equal sign, it's just solving, okay? So minus 4 plus 4, those cancel. So the 8x comes down, equals 4x plus 12, and 4, now I can combine those because they're on the same side, is 16. Same idea. If I want to get my 4x and 8x together, let's get rid of this 4x. I want to put it on the other side. I want to get that 4x on the other side to combine with the 8x. Okay, so I have to subtract 4x from both sides. Those cancel. 16 comes down. And and that equals 8x minus 4x. Now they're on the same side, so I can combine them for x. All right, and lastly, I want to solve for x and just finally get it by itself singularly, okay? I have 4 of them right now, so 4 times x. So if I want to get rid of 4 times x, I'm going to divide by 4, the opposite of multiplication. X comes down, 16 divided by 4 is just 4. If you had trouble understanding the steps here, it is a long process, but what you need to really look up on YouTube or something like that is solving for a variable, okay? That should be the end of this video, guys. You can ask me any questions that you want during class or after school today. I'll be around, again, tutoring on Monday and Thursday after school.